Okay, we are in 8-3 math message. It says Joanna packed 16 bottles of juice into cartons. How could she pack the bottles so each carton has an equal number of bottles with none left over? Show your thinking using pictures or arrays. So you need to show a picture or an array. Then write a number model for each of your representations. So for each of your pictures or array, you'll need a number model at the end. All right, let's figure out what we know. What's important information here? Well, she packed 16 bottles, okay, into cartons. Any other information that we should, circle or underline? There's an equal number of bottles with none left over. So how many do we have altogether? Do we know? Well, we know we have 16 bottles total. And we know we need to pack them in cartons. Does it tell us how much a carton can hold? It doesn't. So that is up to you. Let's say I chose to do 2 cartons. This is my picture. Here's my cartons. I kind of thinking of like milk crates. And I put 10 in this one and 6 in this one. Does it work? Because 10 plus 6 equals 16. But look at this. They need to be equal numbers. Is 10 equal to 6? Or is 6 equal to 10? No. It had to have 10 and 10, which would be 20, or 6 and 6, which would only be 12. So that doesn't work. Whatever's in your picture has to be the same number. They have to be equal. There is more than one right answer, so find at least one way to put all of these bottles into separate cartons with equal numbers. And then if you'd like to challenge yourself, try to find another one. Okay, put me on pause and go ahead. All right, if you are back, that means you have found out at least one way to put these bottles of juice into a carton. You could have just said, I'm going to have one box full of 16. 16 cartons. Well, is 16 equal to itself? Yep. Are all of the bottles in here? You betcha. So remember we need to draw a number model. My number model is 1, because I have 1 carton. 1 carton times 16 bottles equals, well, we know if you multiply any number by 1, it's like having one group of it. So 1 times 16 is 16. Great. What's another way we could have done it? And you could be doing arrays too, but I'm going to stick with my drawing for now. Well, let's see. Can I do it this way? Can I do 2 boxes? Well, let's see. What's 16 broken up in half? Because they need to be equal numbers. Oh, I know that half of 16 is 8. So let's see. 8 plus 8 equals 16. Are 8 and 8 equal to each other? You bet, they're the same number. So I have 1, 2. I have 2 cartons of 8 bottles. And 2 times 8, double it, that is 16. Because remember, we need to write our number model with it. And there is one other way that we can figure out, there's one other way we can figure out if 16 fits into cartons equally. Well, maybe you're like, I'm going to try 3. Okay, well, you definitely could. And maybe I could do arrays, maybe I could do pictures. So there's my 3. And maybe I start off with tallies. 1, 2, 3. And I'm going to tally all the way till I get to 16. So 2, 4, 6, 7, 8, 9, 10, 11, 12. I'm crossing because it is my 5th one. 13, 14, 15. Oh, how many more do I need to fit one more bottle? Can I put this in here and leave it like that? No. So I have 3 times 5, but I have a remainder 1. So that one doesn't work either. But you know what? I know that if I make, let's see, I'm going to do an array this time. So it's like drawing my 4 cartons. I'm going to draw 4 cartons. And I'm going to put 4 in each one. And it's going to make a square of 4 by 4. What is 4 times 4? What is 4 times 4? Well, I know 4 times 5 is 20, so take away 4. would be, oh my goodness, 16. And when we have a number times itself, remember it makes that perfect square. What's that called? Remember, it's called a multiplication square because when I multiply my two factors together, it makes a square when we multiply as an array. Great! Maybe you found one of these three. Maybe you found all three on your own. That's wonderful, but we have a new vocab word we learned today, which is factor pairs. What's a factor pair? Well, we know what a factor is, right? A factor times a factor equals a product. So factor pairs, what would that mean? Well, I'm going to tell you that 1, and that's my and sign, 1 and 16. Oh, let's try it this way. 1 and, I don't know if that's going to be our best spot for that. Okay, 1 and 16, 2 and 8, and 4 and 4 are factor pairs of 16. So I want you to figure out, what does that mean? What does a factor pair mean based on the definition I just gave you, or the example I should say? What does a factor pair mean? Well, 1 and 16 is a factor pair because 1 times 6, or 1 times 16, equals 16. So it's a factor pair of 16. What is 2 and 8 equal when you multiply them together? 16. So it's a factor pair. Remember, pair means 2. So I have 1 and 2 numbers, 1 and 16. That's 2 different numbers. Multiply them together to get your product. 2 and 8. Let's see, there's 1 number, there's 2 number. Multiply them together. 2 times 8 is 16. And 4 and 4 are factor pairs because 4 times 4 equals 16. Would 3 be a factor pair? Would 3 be a factor pair of 16? Could that be one of them? Well, looky here. Remember, we tried to do 3 times, well, question mark. Did it work? Were we able to get 16? No, because we had a remainder. So 3 is not a factor pair because you can't multiply anything times 3 to get 16. You can't multiply one other number times 13 to get 16. So 1 and 16, 2 and 8, 4 and 4 are factor pairs of 16. We can have factor pairs for any numbers, but today we were working with 16. And now when you turn to journal page 259, we'll learn about some more fact pairs. Okay, see ya.